Ancient Greece to the 19th century, the Greek philosopher Aristotle thought that comets were dry exhalations of Earth that caught fire high in the atmosphere, or similar exhalations on the planets and stars. However, the Roman philosopher Seneca thought that comets were like the planets, though in much larger orbits. He wrote, "The man will come one day who will explain in what regions the comet moves. Why they diverge so much from the other stars? Why is their size and their nature different?" Aristotle's views won out and persisted until 1577, when Danish astronomer Tycho Brahe attempted to use parallax to triangulate the distance to a bright comet. Because he could not measure any parallax, Brahe concluded that the comet was very far away, at least 4 times farther. Brahe's student, German astronomer Johannes Kepler, devised his three laws of planetary motion, using Brahe's meticulous observations of Mars, but was unable to fit his theory to very eccentric orbits of comets. Kepler believed that the comet traveled in straight lines through the solar system. The solutions came from English scientist Isaac Newton, who used his new law of gravity to calculate a parabolic orbit for the comet of the year 1680. A parabolic orbit is open with an eccentricity of exactly 1, meaning the comet would never return. A circular orbit was an eccentricity of 0. In the less eccentric orbits are closed ellipses, which means a comet would return. Newton was friends with English astronomer Edmund Halley, who used Newton's method to determine the orbits for 24 observed comets, which he published in the year 1705. All the orbits were fit with parabolas because the quality of the observations at the time was not good enough to determine elliptical or hyperbolic orbits, eccentricity greater than 1. But Halley noted that the comets of the year 1531 and 1607 and then 1682 had remarkably similar orbits and had appeared at approximately 76-year intervals. He suggested that it was really one comet in an approximately 70-year orbit that returned at regular intervals. Halley predicted that the comet would return again in the year 1758. He did not live to see his predictions come true, but the comet was recovered on Christmas Day, 1758, and passed closest to the Sun on March 13, 1759. The comet was the first recognized periodic comet and was named in Halley's honor, Comet Halley. Halley also speculated whether comets were members of the solar system or not. Although he could not only calculate parabolic orbits, he suggested that the orbits were actually eccentric and close, right? For so their number will be determined. Perhaps not so very great. Besides, the space between the Sun and the fixed stars is so immense that there is room enough for a comet to revolve, though the period of its revolutions be vastly long. Many people questions what is comet? What inside the comet? A comet is an icy, small solar system body that warms and begins to release gases when passing closest to the Sun, a process called outgazing. This produces an extended gravitational unbound atmosphere or coma surrounding the nucleus and sometimes a tail of gas and dust. Gas blown out from the coma. These phenomena are due to the effects of solar radiations and the outstreaming solar wind plasma acting upon the nucleus of the comet. Comet nuclei range from a few hundreds meters to tens of kilometers across and are composed of loose collections of ice, dust, and small rocky materials. The coma may heavy up to 15 times Earth's diameter, while the tail may stretch beyond 1 astronomical unit. If sufficiently close and bright, a comet may be seen from Earth without the aid of the telescope and can subtend an arc of 30 degrees, thus 60 moons, across the sky. Comets have been observed and recorded since ancient times by many cultures and religions. Comets usually have highly eccentric elliptical orbits and they have a wide range of orbital periods, ranging from several years to potential several millions of years. Short-period comets originate in the Kuiper belt, or its associated scattered disks. which lie beyond the orbits of Neptune. Long-throated comets are thought to originate in a Oort cloud, a spherical cloud of icy bodies extended from outside the Kuiper belt to halfway to the nearest star. Long-throated comets are set in motions towards the Sun by gravitational perturbations from passing stars and the galactic tide. The hyperbolic comets may pass once through the inner solar system before being flung to interstellar space. The appearance of comet is called apparitions. Extinct comets that have passed close to the sun, many signs have lost nearly all of their volatile ices and dust and become to resemble small asteroids. Asteroids are thought to have different origin from comets, having formed inside orbits of Jupiter rather than in the outer solar system. However, the discovery of main belt comets and active centaur minor planets has blurred the distinctions between asteroids and comets. In the early 21st century, the discovery of some minor bodies with long-period comets orbits but characteristics of the inner solar system. Asteroids were called mass comets. They are still classified as comets, such as C24 is 13 Pastorins. 27 mass comets were found from 2013 to 2017. As of November 2021, there are 4,584 known comets. However, this represents a very small fraction of the total potential comet populations as a reservoir of comet-like bodies in the outer solar system. In the Oort cloud is about 1 trillion. Roughly one comet per year is visible to the naked eye, though many of those are faint and unspectacular. Particularly bright examples are called great comets. So later on, we're going to tackle that. Comets have been visited by uncrewed probes such as NASA JET's impact, which blasted a crater on Comet Tempel 1 to study its interior, and the European Space Agency Rosetta, which became the first to land a robotic spacecraft on a comet. The word comet derives from the Old English cometa, from the Latin cometa or cometus, and turned its romanization to the Greek, wearing long hair. Notes that the term long hair is meant to long-haired star, comet, in Greek, no? To where it is derived the hair of a head and was used to mend the tail of a comet. Now, another interesting problem for the astronomers was a comet discovered in 1826 by the Australian military officer and astronomer Wilhelm Prayer Baron von Bella. Calculations of its orbit showed that, like Encke's comet, was a short-period comet. It had a period of about 6.75 years. It was only the third periodic comet to be confirmed. It was identified with a comet observed by French astronomers Jacques Levax-Montaigne and Charles Messier in 1772, and by Fons in 1805, and it returned as predicted in 1832. In 1839, the comet was too close in the sky to the Sun and could not be observed, but it was seen again on schedule in November 1845. On January 13, 1846, American astronomers Matthew Maury found that there was no longer a single comet. There were two, following each other closely around the Sun. The comets returned as feared in 1552, but were never seen again. Searches for the comets in 1865 and 1872 were unsuccessful, but a brilliant meteor shower appeared in 1872, coming from the same directions from which the comet should have appeared. Astronomers conclude that the meteor shower was the debris of the disrupted comet. However, they were still left with the question as to why the comet broke up. That a recurring meteor shower is now known as Andromedes, named for the constellations in the sky where it appears to radiate from, but it is also sometimes referred to as Pleiades. Astronomers continued to ask where do the comets came from. There were three scholars of thought that comets were captured from interstellar space. The comets were interrupted out of the giant planets. Then the third, that comets were primeval matter that had been incorporated into the planets. The first idea had been suggested by French mathematician and astronomer Pierre Laplace in 1813, while the second came from another French mathematician, astronomer Joseph Lagrange. The third came from English astronomer George Chambers in 1910. The idea of interstellar origin for comets ran into some serious problems. First, astronomers showed that captures of an interstellar comet by Jupiter, the most massive planet, was highly unlikely event and probably could not account for the number of short-period comets then known. Also, no comets had ever been observed on truly hyperbolic orbits. Some long-period comets did have orbit solutions that were slightly hyperbolic, really above an eccentricity of 1.0, but a truly hyperbolic comet approaching the solar system with the sun's velocity relative to the nearby stars of about 20 km or 12 miles per second would have been eccentricity of 2. So now, we're in Encke's comet. The German astronomer Johann Encke was the second person to recognize a periodic comet. He determined that a comet discovered by a French astronomer Jean-Louis Pons in 1818 did not seem to follow a parabolic orbit. He found that the orbit was indeed a closed ellipse. Moreover, he showed that the orbital period of the comet around the Sun was only 3.3 years, still the shortest orbital period of any comet on record. Encke also showed that the same comet had been observed by French astronomer Pierre Méchain in 1786, by British astronomer Caroline Herschel in 1795, and by Pons in 1805. The comet was named in Encke's honor as Comet. Halley was named for the astronomers who described its orbit. Encke comet soon represented a new problem for astronomers because it returns so often its orbit could be predicted precisely based on Newton's law of gravity, with effects from gravitational perturbations by the planets taken into account. But Encke's comet repeatedly arrived about 2.5 hours too soon. Its orbit was slowly shrinking. The problem became even more complex. It becomes discovered that other periodic comets arrived too late. Those include the comets of 6 feet arrested, 14 feet 1, and even 1F Halley, which typically returns about 4 days later than a purely gravitational orbit would predict. Several explanations were suggested for this phenomenon, such as resisting an interplanetary medium that caused the comet to slowly lose orbital energy. However, that idea cannot explain comets whose orbits were growing, not shrinking. German mathematician and astronomer Friedrich Bessel suggested that expulsions of materials from a comet near perihelion was acting like a rocket motor and propelling the comet into slightly shorter or longer period orbit each time it passed close to the sun. So the history would prove Bessel's right. As the quality of observations and mathematical techniques to calculate orbits improved, it became obvious that most comets were on elliptical orbits and thus were members of the solar system. Many were recognized to be periodic, but some orbit solutions for long-period comets suggested that they were slightly hyperbolic, suggesting that they came from interstellar space. That problem would not be solved until the 20th century. So here comes the Great Comet of the year 1577. Approximately once a decade, a comet becomes bright enough to be noticed by a casual observer, leading such comets to be designated as great comets. Predicting whether a comet will become a great comet is notoriously difficult, as many factors may cause a comet's brightness to depart drastically from predictions. Broadly speaking, if a comet has large and active nucleus will pass close to the Sun and is not obscured by sun as seen from Earth when at its brightness, it has a chance of becoming a great comet. However, Comet Coty in 1973 fulfilled all the criteria and was expected to become spectacular but failed to do so. Comet West, which appeared 3 years later, had much lower expectation but became an extremely impressive comet. The Great Comet of 1577 is a well-known example of a great comet. It passed near Earth as non-periodic comet and was seen by many, including well-known astronomers Tycho Brahe and Tycho Aden. Observations of this comet led to several significant findings regarding cometary signs, especially for Brahe. The late 20th century saw a left gap without the appearance of any great comets, followed by the arrival of two in quick successions. Comet Hyakutake in 1997, followed by Hale-Bopp, which reached maximum brightness in 1997, having been discovered 2 years earlier. The first great comet of 21st century was C 2006 P1, Mach 0, which became visible to naked eye. Observers in January 2007, it was the brightest in over 40 years.